here we go, moving on to page 4. So here's a summary of what we've determined, right? Okay, so if we have a simple random sample of size n that we've drawn from a population with mean mu and standard deviation sigma, then the sampling distribution of x bar has mean mu sub x bar equals mu, right? So the mean of the sample means is the same as the population mean. And the standard deviation, sigma sub x bar, right? The standard deviation of the sample means is sigma divided by the square root of n. This thing is sometimes called the standard error of the mean. I'm never going to call it that, but you might have a question, homework or something that asks you to compute the standard error of the mean. That's what they're talking about. They're talking about the standard deviation of the sample means. And then the shape of the distribution. Well, if the underlying population is normally distributed, then the sample means are also going to be normally distributed. Okay? Okay. So we can use that information to compute some probabilities involving x bar. So if you remember back to when we first started this discussion, we said the whole reason that we wanted to be able to describe the sampling distribution of x bar is so that we could compute probabilities involving x bar, right? We needed to know what the underlying, we needed to know what the distribution of x bar looked like so that we knew what calculator we could use in StatCrunch to compute probabilities involving x bar. Well, if x bar is normally distributed, then we can use the normal calculator to compute probabilities involving x bar. So let me give you a couple examples of this. So working with IQ scores again, right? This one says, scores on an IQ test are normally distributed with a mean score of 100 and a standard deviation of 15. Compute the probability that a random sample of size 10 will have a sample mean less than 105. Okay. So in other words, we want to compute the probability that the sample mean, x bar, is less than 105. Okay. I'm being very intentional with the symbols that I use. Okay. And I want you to do the same. So notice that I'm not writing probability x is less than 105. This has a completely different meaning, right? This is like the probability that if you randomly choose one person, what's the probability that their IQ is less than 105? This one is saying if we randomly select a sample of 10 people, what's the probability that their sample mean is less than 105? And maybe I'll compute both of these in StatCrunch just so that you can see the difference. But let's answer the question at hand first, right? So if we want to compute the probability that our sample mean is less than 105, well, we know that the sample means are normally distributed. So we can use the normal calculator in StatCrunch to do that, right? So we're going to go to Stat, Calculators, and Normal. Okay? We know that x bar is normally distributed because of the simulations that we just ran. We know that x bar is normally distributed. So Stat, Calculators, Normal. Once we get there, we're going to have to enter something for the mean, and we're going to have to enter something for the standard deviation. Well, we don't want to enter the mean of, we don't want to enter mu and sigma for the mean and standard deviation. We want to enter mu sub x bar and sigma sub x bar, right? Because we're trying to calculate a probability involving x bar. So we want to enter mu sub x bar and sigma sub x bar. Well, mu sub x bar happens to be the same thing as the population mean, which in this case is 100. Okay. The standard deviation, though, sigma sub x bar, that is not the same thing as the population standard deviation. it is the same thing as the population standard deviation divided by the square root of the sample size, right? So population standard deviation in this case was 15. The sample size was 10. So I'm going to punch that into my calculator and see about how much that is. So 15 divided by the square root of 10 is approximately 4.74. So I'm going to say this is about 4.74. Okay, so those are the values that we're going to enter for the mean and the standard deviation when we go to do this in StatCrunch. Okay, so I'm going to go do this in StatCrunch now. Again, we're looking for probability x bar is less than 105. Let's see what we get. Okay, so it's stat, calculators, normal. For the mean, we said we're going to put in 100. And for the standard deviation, we said we would put in 4.74. And, okay, and now we want the probability that x bar is less than 105. Okay, so you hit compute. And there you go, right? There's our probability. So about 0.8543 if we round to 4 decimal places. So I'm going to say this is about 0.8543. Okay. I'll take you back to the notes in a second, but for the sake of argument, right? I just wanted to show you what you would get if we had done this the way that we did things, back in chapter 7 or whatever. So I'm going to open up a new normal calculator so I can do this again. Okay, if we weren't talking about the probability that x bar is less than 105, if instead we were just talking about the probability that x is less than 105, then we wouldn't have to adjust the standard deviation, right? We would just say, well, the population mean is 100 and the population standard deviation is 15, so we would put in 15, and then we would say, okay, what's the probability that x is less than 105? And we hit compute, and you see that you get a different result. Okay, you get a different result there. So this probability is the probability that if you randomly select one individual, that individual has an IQ less than 105. This probability is the probability that if you randomly select 10 individuals, their sample mean is less than 105. Okay. The only difference between them is what you enter for the standard deviation. Okay. So if you're talking about just one individual, then you put in the population standard deviation that the problem gives you. If you're talking about 10 individuals, then you put in the population standard deviation divided by the square root of 10. More generally, if you're talking about a sample of n individuals, then you put in the population standard deviation divided by the square root of n. Okay, and that's what you put in here. So that's how you calculate probabilities involving x bar, at least when the underlying population is normally distributed. When the underlying population is not normally distributed, well, we haven't talked about that yet. We'll talk about that later on in this section. But let's do the second example. So going back to the notes real quick, number 4, part B says, oh, by the way, so here's our answer to part A, right? So I wrote that down earlier, right? Probability x bar is less than 105 is 0.8543. Now part B says, compute the probability that a random sample of size 10 will have a sample mean greater than 110. Okay, so we want probability, well, let me write the other stuff first. So we're going to say, we know x bar is normally distributed. We're going to go to stat, calculators, normal. For the mean, we're going to put in mu sub x bar, which is 100. We know that because we already did this in part A, right? We already did all this work. Sigma sub x bar we know is about 4.74. And then we want the probability that x bar is greater than 110. Let's see what we get. Okay, probability x bar is greater than 110. Okay, and there we go. About 0.0174. Okay, so that's how we compute probabilities involving x bar when we know that the underlying population is normally distributed. If the underlying population is not normally distributed, right, then we don't know what the shape of the distribution is. Then we don't know what the shape of the distribution of x bar is yet. So we're going to have to run some more simulations. Let me start a new video, and then we'll look at page. What are we on? Page 5, I guess. So let me start a new one.